All right, Jam, as we approach the holidays, it's time to talk about something that is very important to me as a person who uses the bathroom and spends holidays with family.
Okay.
And that is Poopourri Toilet Spray.
Oh, I was like, why are these things even related? It's like, doesn't everyone go to the bathroom and don't most people visit family and probably have to go to the bathroom at some point while they're there?
Yeah, but I personally have a lot of bathroom shyness, and these sprays have changed my bathroom experience.
Okay.
So I, of course, wanted to know the chemistry behind them.
Yeah. Okay, interesting. I have used these before. I'm not very bathroom shy, but I have used them, and I have thought this actually works pretty well.
Better than you'd think, right?
Yes.
Mm-hmm. I was like, this is probably low-key a scam. It doesn't seem to be.
Yeah.
So I have been pleasantly surprised.
Yeah. Okay, interesting.
Okay, so do you want to talk about the chemistry behind it?
Let's do it.
Let's do it. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
Okay, so I've wanted to do this for a while.
Mm-hmm.
And I feel like it is a little unorthodox, because this is something that is sort of an industry secret, right? They don't just tell us exactly what's in it. It's like a blend of essential oils or something. It's like kind of what they say.
Uh-huh.
And you can find some information, like we call it a safety data sheet that has like chemical information. It gives me a little bit of insight, but a lot of this is what I would call chemistry off the cuff.
Got it. Okay, cool.
So it's a little bit more chemistry off the cuff from me than is usual. Normally, if this is your first episode joining us, typically what I do is I do have a background in chemistry. I have a PhD in chemistry, master's in chemistry, bachelor's, all of them.
You could call it a background, or you could call it like her life story. I don't know.
Yeah, one of those. I have expertise.
Yeah.
But so usually I'll do a deep dive through literature and a lot of trustworthy sources. But this was harder to find those kinds of sources for because it's like a product. So I had a similar problem with expo markers.
Okay.
I did end up doing a short episode of similar like this on those, I think. So it will be a little, off the cuff.
Okay.
But I think I've come up with a pretty good reason for how these things tend to work and a little bit of fun chemistry aside to it.
Nice.
So it's kind of like a little, I've been wanting to do this for a while and now's finally the time.
Nice. What's timely about this is that only in the last couple of years have I really even used this product, because at Stoke, at the co-working space where I work at least 2 or 3 days a week from there, some amount of time. Shout out Stoke. There's some real ones right there. They, in their bathroom, have this section that I've always thought was hilarious. It's like a little kind of shelf cubby kind of thing mounted on the wall. And it has 2 items in it. One is a Poo-Pourri, and one is a Febreze air freshener. And on there is written before and then after. I think
That's funny.
That appeared to maybe the second or third week I was there. And I was just like, this is helpful for sure, and also this is just a funny way to do that.
Yeah.
But where I'm not very bathroom shy, at the same time, when I've walked into the bathroom there and there's been any odors left over, I've thought like, oh yeah, this is just unpleasant to walk into. And in a home, a bathroom's not getting constant back-to-back use.
Yes.
But like an office space or whatever, clearly that's happening quite a bit. A lot of people there sharing, not that many bathrooms. And so I was like, yeah, I'm going to do this so that I don't cause a situation for somebody else.
To walk into something unpleasant.
Yes. Yeah. And I don't have to go crazy. I'm not going to use the whole can of Febreze or whatever, but it's just a little bit will help somebody else's experience be that much better.
Yeah.
And that's the first time I've really been like, oh, okay, that'd be great. Whereas at like a home or something, I generally feel like, oh, do I want to keep buying this thing and have to have it all the time? Is one more thing to keep on the grocery list. And it feels like too much trouble. Yeah. So all that to say, I've used it. It seems to work.
Yeah.
I'm interested.
I don't love Febreze scents a lot of times. So for like a cover up smell after the fact, I've never been a fan of those.
Yeah.
I'm like, does this even really work? So for the after part, I'm like, nah, I don't know.
Yeah.
But I do use the Poopourri spray before you go type spray. Specifically in family gatherings where there's a shared bathroom that a lot of people are using. Like we're all staying in one house.
Yeah.
And we're all going to be going number 2.
Yeah.
You know? It's like, it feels more like the office situation where it's like, all right, we can at least keep these down to a little bit of a minimum. So it's not like I keep it at my house.
Right.
I'll keep it in my guest bathroom.
Yeah.
You know?
Smart.
And when we all get together, I'll keep that.
Yeah.
So,
yeah.
and it was a lifesaver for me when you're traveling with work people. You're like, I don't really want to be you smelling anything happening.
Yeah.
And so it is really, it's like, it comes in clutch for me. I don't want other people to smell my bad smell. And I don't really want to smell the bad smell of other people, you know?
Right. And that's where it's like having this in your own like guest bathroom or putting it in a bathroom at like a shared space at a workspace or whatever is like this helps me more than you if you actually use it. You know?
Exactly. So, and I do want to shout out our community member, Tim, because I'm pretty sure he and I have also discussed this before. It's like, how do we think that this works? And so, shout out to him.
Yeah.
So, of course, as a consumer product, I'll say, like I mentioned, there's not a ton of information on how it works. One thing we do know is it's a mix primarily of oils, like essential oils.
Okay.
And I think that it being oil is a key factor for how it works. But first, let's talk about what makes our excrement stinky in the first place. So there are 2 main things that scientists cite when discussing the smell of human feces.
Okay.
And one is a molecule called skatole.
Okay.
It's produced by bacteria in the gut when breaking down tryptophan. Tryptophan, an amino acid we've talked about before.
And we talked about how it gets all that reputation around being in Turkey around the holidays, and yet it's in like tons of stuff. And our body makes it, right?
I can't remember that for sure. I don't want to comment.
It's in one of those episodes we did that you could go listen to instead of hearing us get it wrong.
I hope we remember.
Yeah.
It's not the thing that probably makes us sleepy for Thanksgiving. Spoiler alert.
Yep.
But we talk about what probably does. So yes, it's in a lot of things.
Okay.
So these bacteria, they break down tryptophan. They make this skatole, which is a bad smelling molecule, in large quantities. In smaller quantities, skatole is considered a good smelling compound and is often used as a component of ice cream, and it is part of what makes flowers smell good. So it's like, if you get it in a little bit, it seems pleasant, but then if it overwhelms, then it starts to seem negative.
Weird.
Isn't that weird?
Yeah.
So that's kind of like a fun, weird chemistry fact.
Yeah. It's like, oh, wow, you like the smell? Wow, you don't even like flowers then, too. Okay.
Yeah. You don't like the smell of poop?
Yeah.
It is hard. Sometimes, I don't know if our listeners know this about me, but sometimes I do like to use curse words in comedic effect. I think they're funny.
Yeah.
And this is a prime episode for that.
Yeah. And it also just plays to the immature side of my humor.
Yep.
My kids right now are in this stage, 2 of them at least, where they just like to kind of create an excuse. They know we don't want them to talk about poop and any sort of potty talk like that apart from the potty.
Yeah.
You know, it's like when you're needing to use those words, it's useful, all that kind of stuff. They're not bad words. But when you're using them just for humor, another place is just gross, right?
Yeah.
Trying to establish that as a norm for them. So they try to find these sneaky ways of just getting around that, where it's like my middle son will be like he'll pretend like he's telling a story about a time that he was using the potty. But he just will be like, and then I don't know if I should say this or not. It's not bad. It's just
I think it's funny. I think
immature. Okay. Like, and I poop in the potty and I flush it down like that. And it's like, I think you just wanted to talk about poop.
Yeah.
You know, like that didn't happen today yet. Like there's not a particular, that story's not unique. There's nothing about this like, oh, right. There was one time when something crazy happened.
Yeah.
And he'll also just sneak it into sentences in different places to see if we're like noticing
it.
And so there's a bit of me that I'm going to have to be self-controlled about
I was going to say that must be hard for you to teach them to not use that kind of humor.
Yep. Yeah.
You're like, I'm just trying to help them out to not be crass because they don't know when to use it yet. But man, I love a well-placed joke.
Right. And that's the thing is like, I think once they get to that point where they're crafting some pretty good jokes about, anything under the sun, including poop, I'll probably be like, okay, don't do that all the time, but that was good. I gotta give you props.
That one.
That's the kind of stuff. Save the pod talk for the good jokes.
Okay, so that's one. Skatole is the one. And then the second one is sulfur. Like hydrogen sulfide is the classic rotten egg. It's a gas that smells like rotten egg.
Mm-hmm.
And many thiols, which are sulfur molecules, we call them thiols.
Mm-hmm.
Similar to how we call oxygen bonded to a hydrogen alcohol. A sulfur bonded to a hydrogen is a thiol.
Okay.
Many of those have that smell, that like, oh, this smells bad, like passing gas kind of smell. So those are the two main molecules. And I have a theory on or two types of molecules, I guess, on how this poop spray works.
Okay.
But, well, I guess I kind of have two. But let's say this primarily is an oil-based spray.
Okay.
Which means that when you spray it, it creates sort of a coat on the top of the water.
Mm-hmm.
So if it sits on top of the water, and you can kind of see this when you spray it. So like, I'm pretty confident this is what's actually happening. It means sort of two things. It's sitting on top of the water. It must be less dense than water. Because if those oil molecules were heavier, they would sink down.
Right.
And we've seen this before. You made that graduated, like you use different house products, you know, and you
the chemistry
things.
at home that we did. Yeah, I was just thinking about that.
So I think that one important thing, this is again off the cuff, is that this is probably a lighter weight oil than water.
Okay.
That's my guess.
Okay.
Or less dense than water. And then the second thing is it's not soluble to an appreciable extent with water.
Okay.
And I looked up some of the safety data sheets, and there's like, it has some solubility with water, but not a significant amount from what I could tell.
Okay.
So let's do a quick chemistry lesson on solubility. So we've talked about this before, but in general, like dissolves like in chemistry. So if we have a really polar molecule, which water is, that means that it has an area of higher electron density, which means there's more electrons in this area. Electrons are negatively charged. So this area is negative, and then the area nearby it is positive. The area that it's taken the electrons away from.
Okay.
So we sort of get a pole. It's similar to where you have like magnets and one side and another, they're both negative. You bring them together, they repel each other, whatever. So what happens is if you get the negative and the positive side of those molecules together, they'll be attracted to each other. That's intermolecular forces, and water is really polar and it likes to interact with other polar things. And then non-polar things tend to like to interact with other non-polar things. And so in general, we have that rule like dissolves like. Well, many oils are non-polar. So when you mix water and oil, like if you're cooking and you drizzle a little olive oil in your boiling pasta water, you might see it float on top. Okay? So if it's floating on top, it's like, okay, yeah, this doesn't want to interact with the thing below it.
Right.
Okay, so here's my theory on now how does all this come in together.
Okay. So
we have this bowl of water and we spray oil on top of it. So when we go to the bathroom, the excrement lands in the bowl. And if you don't have anything on top of the water, those molecules, which at least sulfide is definitely gas at room temperature, hydrogen sulfide one, they must be able to rise up out of the water and then get to our olfactory.
Yes,
and
good
our
olfactory.
nose, good olfactory, and we then will detect their presence. So if we could put a barrier to where they can't rise out of the water, then okay, we might not be able to smell them. Or at least a barrier where less are able to do that at least.
Right.
So if these primarily polar, smelly molecules are in the water, they can interact with water pretty easily.
Mm-hmm.
Like the sulfur is pretty polar. The skatole has some polar parts to it. So they would be able to interact with water pretty easily, move through the water pretty easily, and eventually rise to the surface pretty easily.
Okay.
But now imagine if on top of that water, we spray this layer of oil, which sits on top of it, doesn't sink down, provides kind of a coating. And so now on top of all these polar water molecules, we have a non-polar layer.
Yes.
And this would, in my estimation, if you have a polar something, start to rise up, it's moving around, it's trying to get out from the water, it finds a non-polar thing, it's like, nah, I'm not really interested in interacting with that, and it goes back down a different way into the water.
Mm-hmm. Mm-hmm.
So I think it acts as a literal barrier because its non-polarness allows it to not interact with the water, and its density allows it to sit on top of the water, doesn't sink down. So it literally makes a layer of nonpolar molecules on top of the water that will make it difficult for anything to rise out.
Wow.
This is my theory.
Wow. Interesting.
Right? Isn't that crazy?
Yeah. It's weird because it's cool how kind of chemistry 101 it is in a good way.
Mm-hmm.
In like it's a very simple but ingenious solution.
Right.
To solving a very everyday problem.
I know. And even I saw on the Poopourri website where it was like, and I did cite some resources here. It's not like I didn't do anything. I cited some resources about skatole, and I did go visit the Poopourri website.
Mm-hmm.
But they mentioned like, oh, even if it like sort of comes back up out of the water, typically it'll go down under the water and then peak back up. And then even just like the excrement itself will have a coating of the oil on it from when it comes back out. And so even if it's not completely submerged in the water, it can still sort of have a coating of these nonpolar molecules.
Yeah.
So
interesting. Wow. Bit of a force field of sorts on the surface of the water, and even around the actual stuff.
Yeah.
Huh.
I even wondered, I'm like, what does the density have to do with things? And this isn't really like an area that I spend a lot of time thinking about as an organic chemist. But I'm like, would the density of these gas molecules play a role? Like if the oil is less dense than water, what if the density of the gas is like somewhere in between? But then that doesn't seem right because individual gas molecules can move around a lot. And usually when we think of density, we're talking more about liquids. So then I kind of got unsure of myself. So that was something that I also wondered. And then I also wondered sort of about like water has a high surface tension.
Yeah.
So I wondered like maybe is the surface tension of water allowing there to be like an interface there with the oil? I'm not for sure. So there's some other things that came to my mind that I was like, oh, these could be things too.
Yeah. But
this was my best guess and the theory that I think Tim and I originally talked about that makes the most sense to me about, okay, this is how I think these work. And the more I think about it, the more I'm like, yeah, this does seem to be how these work out.
Yeah. Huh.
So do you want to try to summarize that back to me?
Yes.
Your little chemistry 101 lesson?
Yes. So it starts with, the thing we're trying to fight here are these particularly smelly aspects of our excrement. So, man, I had the first one and then it just escaped me. Skatole. Okay. And then the other one was there two main ones? I lost the other one.
Rotten egg smell?
Yeah. Oh, sulfur. What? Sulfur ox.
There's hydrogen sulfide is
H2S.
H2S.
Okay.
But thiols is the name of it's the functional group. We've talked about functional groups a few times. Sulfur bonded to hydrogen on a carbon chain is usually that's called a thiol. Okay.
Thiol, and then hydrogen sulfide and skatole. We've got these things that are interplaying in these larger quantities that do not smell good to us.
Yeah.
And
I think sulfur might smell bad even in small quantities.
yeah, that does seem like one that would be hard to be like, actually, this is kind of nice.
It's weird that skatole has that, though.
What a nice, subtle, sulfury smell you've got going on here.
Subtle, sulfury smell. Dude.
Unless it's just like not very detectable. But I'm like, do eggs smell a little sulfury no matter what? And it just...
Sometimes it's not
gets overpowering.
Pleasant. Yeah. I think about that. Didn't you go to like a place that smelled strongly of sulfur when you were in New Zealand?
Oh, yes, I did. Mm-hmm.
That's how I felt at Yellowstone.
Rotorua. Yeah.
Yellowstone was similarly like, it's very sulfury here. I just don't know how I feel about it.
Yeah.
Yeah.
So that's what's going on. That's some of the biggest players in the smell department of what's happening in the bathroom. So those things are polar, just like water. And one of the, literally the first episode we ever did, and then several, countless across the years have had to do with this polar, non-polar nature of different molecules.
Yeah, it was our very first one. Yeah.
And so what's happening when the excrement lands in water and those molecules are there, they're actually able to interact with water pretty easily and maybe float to the top and even just become gas and evaporate and be kind of out in the air where we can smell them. And so somebody somewhere at some point had this idea that because of the fact that polar stuff does not want to interact with non-polar stuff, like you said, that was the first thing I thought of too, like the olive oil and your pasta water. It wants to. It's both wanting to stay with itself, and it's less dense than the water. It wants to stay on top, and so doing this fine spray across the surface of the water in the toilet bowl creates this layer of non-polarness. So when the skatole and hydrogen sulfide and stuff wants to kind of come up to the surface and out, it is hitting this non-polar layer, and it doesn't want to interact with that. And the non-polar doesn't want to interact with those either. They want to stay away. And so maybe it's enough to prevent enough of the stuff from getting out of the toilet bowl into the air and smellable, and do a notable decrease on that. Because I was thinking too, like most times I do a fine spray, and I'm like, how much would it take to really have a good, layer? But it's at least something,
right?
And so then, if it can't even escape in the first place, then it cannot be in the air where we could smell it.
Right.
Is that right?
Yeah, and I like this is sort of different than the approach of Febreze and other sprays that are like trying to trap the odor molecules that are already in the air. It's like, let's contain it to this one area. And I do think it's not perfect. It's not like, oh, I used this and now there's no smell at all.
Right.
But it does seem like it pretty significantly lessens it, and not just in a cover-up way. Like, oh, I can still smell that smell underneath. It does seem like it literally minimizes it. So I'm like, yeah, if we got a pretty good coverage here, there's less literally able to escape.
Yeah.
So it minimizes the number.
And so that them adding the scents to the Poopourri is like a sort of their backup plan.
I think
in a way, because their main function is the other thing, but it's like it does mask it, a little gives you something else to smell.
Yeah.
But it's nice that it's not just that's all there is. It's not just an aroma they're adding to the toilet bowl.
Right.
Because that would be like, great, this is just the same as Febreze.
But a lot of essential oils are those non-polar molecules that are oils. So it kind of is like a nice, like, oh, this will be a non-polar thing and it will have a nice smell to it.
Yeah, it does smell quite nice. And what is nice about it is that it's adding that aroma to the room beforehand a little bit, which already does seem like I don't know, it's getting ahead of it to a degree.
Yeah.
In the air, but yeah.
Great.
Interesting.
I had thought about doing categories in one podcast that I listen to, sometimes called Tooth and Claw, which is a bear biologist talking about human-animal conflicts. They, one time for their categories, which is where I got this from, they said, like, what's the best place you've ever taken a poop, or like best place you've ever used the bathroom or something like that.
Oh, wow.
And one of them was like, it was in an outhouse overlooking a beach, and there wasn't like a door or anything. And they were just like using the bathroom, looking out on the ocean. And I was like, that sounds terrible. I don't think I could do that. So then I was like, what would be a fun or funny category? And I couldn't think of one.
Dang.
But I did think maybe, what is the worst smell you've ever smelled? Or what's the best smell that you've ever smelled? Or like a one that stands out as a really good and a really bad?
Huh.
I think we might have done a good smell before.
Yeah.
So
That's good. Do you already have one on the smells?
no, I didn't think about it ahead of time. I thought about the category and then paused.
I mean, one that comes to mind so quickly is
one came out. Okay, go ahead.
It's just coffee smells great, and because I have such an affinity for it, it's like I never get tired of it.
Mm-hmm.
And I was giving somebody a bag of coffee the other day, and they were like, I handed it to them, and you know, like with the bags, when you kind of squeeze it, a little bit of that can come out. It's like that one-way valve on there. And they were like, oh my gosh.
I love that.
You know, and it was just one of those like, yeah. It reminded me like, yeah, I smell this all the time, so I get a little used to it, but it is very good.
I don't love drinking coffee. It gives me the shakes, so I can't just drink it the same way I used to.
Mm-hmm.
But I love smelling those bags.
Mm-hmm.
They're so good.
Whenever we have our staff meetings every week at Loco Cafe here in Denton. Shout out Loco. Shouting out local businesses today. Stoke, Loco, you know, just kind of what we're doing on accident.
Yeah.
They will.
I just had Golden Root.
Oh.
Yeah, I went to Greenhouse and I had Golden Root ginger beer there, which is a locally brewed ginger beer, non-alcoholic.
Nice.
It's called beer because it's brewed, I think.
Yeah.
And that is a tasty beverage.
Nice.
Okay, go ahead.
So they will grind like large amounts of coffee because they're doing these big batches.
Mm-hmm.
We're there and they do that. You know, there's like all kinds of kitchen sounds, so I don't really notice. But I will get hit with the wall of like they've just ground like 200 grams of coffee or whatever. And just this wall of intense coffee aroma just like sweeps across the room.
I love that.
So that's definitely one of my favorites.
So a bad smell I just remembered is my mom didn't usually pack us lunch. Okay, so we'll like go buy lunch.
Yeah.
Okay, and in our house, it was a summer break, and there was a terrible smell in our house, and my mom was looking all over for it, like could not figure out what it was. Narrowed it down to my sister's room. Was in my sister's room trying to figure out what is the smell. What is the smell? What is the smell? She comes upon my sister's backpack. And in my sister's backpack is a Ziploc baggie full of rotten broccoli.
Oh, gosh.
And broccoli, like, sometimes can smell a little sulfury.
Right. It's already got, like, a stronger smell than some of the vegetables.
Yeah.
Yep.
And it smelled so bad. And my mom was like, what is this? Where did this come from? And she's like, I traded for it at school and then forgot about it on the last day of school. And so it just sat in her backpack because you don't need your backpack in the summer.
Right.
Just rotting.
That's bad.
So I do remember that being a really bad smell. And I also remember being like kind of a hooligan as a child and getting cups of milk and not finishing them and leaving them in my room.
Oh, yeah.
And milk that's gone sour, it's like, I want to gag just thinking about
that's
that
bad
smell.
for
So
sure.
those are two bad smells that stand out to me.
Yeah, those are good ones. Dang. There's this very distinct, and I have my own word for it, which is kind of gross. A very distinct smell that I kind of remember the first time, like I experienced it, or I guess the first time I remember experiencing it.
Mm-hmm.
The smell of like, not just your average dumpster, but like bigger ones, like at a school, for instance. This is what I remember. I remember smelling this in this area at our middle school where they had several dumpsters. It was also like the place where you kind of had to walk out to go if we were like doing band practice outside for marching band.
Yep.
And so several dumpsters in a row. And there's something about the smell of like a bunch of trash.
Yep.
There's also food waste in there and stuff. But it smells to me just a little, and I bet there's something to this. Probably we could point out some sort of similarity in terms of molecule or something. Something that smells just a little cheesy to me. In like it's like, this is some weird artificial stinky cheese. A mixture of like the stinky kinds of cheese that are like high quality, I guess.
Yeah.
And like Cheese Whiz that's like has that cheesy smell, but is also like whatever else is going on in there.
Yeah.
And something about dumpsters of that caliber
smell like that too.
Have exactly that smell. And so like when we walk by the elementary school near our house, I'll sometimes get a whiff of that exact.
Yeah.
It's like this school food and kids with gross stuff to throw away or whatever.
Yeah.
And it being enough of it to really,
especially in Texas in the heat, it's like it probably ferments in there a little, which that's what cheese is doing too.
Yep. That's where I think I get that cheese part to it, because there's a lot of things that like are those sort of aged foods that have yeast and bacteria and stuff like that to them. But
well, here, let's give you a palate cleanser. So you started with your favorite drink smell. My favorite drink is cinnamon tea. And I love the smell of cinnamon. Sometimes our local coffee shop, shout out Jupiter House, you walk in and they'll be baking cinnamon rolls. And
that's true.
I do love the smell of cinnamon.
That's good. That was a very, very good palate / olfactory sensor. Sometimes you guys got to clean out that olfactory.
And if you don't know why he's saying that, go check out our episode on why things smell at all.
Yeah.
Well, I think this would be a good place to wrap it up. So thank you, Jam, for that good summary and for letting me talk to you about really a theory I have. There's not a ton of evidence to support this except what I know about how molecules work.
Right. It's like there's tons to support polar and nonpolar stuff.
Right. Yes.
Like, good luck disproving that.
But about specifically, I mean, I wish I could talk to somebody at Poopourri and hey, Poopourri, sponsorship, we're here for you.
Yeah. We're users of your product. We're fans. And the way y'all used chemistry in a way that helps everyday life. That's kind of like what we're all about here.
Right.
So
we're here for it.
Well, thanks for teaching us.
Yeah.
This is very everyday life. Very cool. If you have a question, thought, idea, comment, follow-up, correction, anything like that about chemistry in everyday life, in your everyday life, and everybody's everyday life, whatever, reach out to us on our website at chemforyourlife.com. That's chemforyourlife.com and share your thoughts, ideas, questions with us. If you'd like to help us keep our show going and contribute to cover the cost of making it, you can join our super cool Chem community of Patreons on patreon.com/chemforyourlife. That's where Tim, who asked this question at some point, we're pretty sure, that's where he hangs out and asks questions and answers stuff, and our whole other crew of folks. We'd love to have you over there. And it's just a great way to keep the show going, keep it free for everybody else. You get ad-free feed of the show. You get some behind-the-scenes stuff here and there. You get a monthly bonus episode just for y'all. So, yeah, it's pretty cool. And those are just ways of us saying thank you to you for helping the show continue existing and for letting it be shared with everybody else for free. If you can't do that, there's a few other ways you can help. You can buy merch on our merch store. It's a great one-time way to support the show and represent chemistry wherever you go. And
I've gotten so many compliments on my Ghost Halloween Erlenmeyer Flask merch this month.
Yeah, so we've got that going on right now. We have some of those like holiday-specific kind of things, but year-round, there's some good stuff on there. So check it out whatever year, month you're listening to this at chemforyourlife.com/store. That's chemforyourlife.com/store. You can also help us by just subscribing to your favorite podcast app, writing a review on Apple Podcasts and Spotify, subscribing on YouTube. Those things help us to be found by other people and have the chemistry of their everyday life explained for them.
And like Jim said, those community members really help keep this podcast going. And so we think it's important to shout each and every one of you out. So, sorry, I've got the sneezes. So sorry if I have to pause in the middle of this. So we want to say thank you to Emily M, Kyle M, Emily H, Ash, Vince W, Julie S, Heather R, Autoclave, Chelsea M, Doreen V, Scott B, Jesse R, Sierra L, John T, Jeanette N, Cullen R, Erica B. It's just so fun how many people are here. Elizabeth P., Rachel R., Latila, Katrina B., Suzanne P., Venus R., Jacob T., Brian K., Christina G., Timothy P., Stephen B., Chris and Claire S., Chelsea B., Avishai B., and Hunter R. Thank you all so much for everything you do to make this podcast manageable for Jam and I and to keep this show going. And if you'd like to learn more about the resources we used in today's episode, please feel free to check out our show notes on our website or in the description below the video, depending on what platform you're using. And
yay, chemistry!
Thanks for making bathroom experiences better.
Yes.
Woohoo!
After, I guess, making them worse in the first place, right? Because chemistry kind of does that too.
Yeah, I guess it's just the tryptophan. Yeah. You're so right. Making it worse, but then better.
Yeah.
Or is it biology's fault? Okay, I'll just leave that there for the biologists. Bye.